Hello, and welcome to yet another thrilling installment of the pre-calculus and Algebra 2 notes. This is a section about graphing polynomial functions. So we're going to graph polynomial functions using key features. So, we have this polynomial here, and what we're going to do is we're going to be able to sketch a graph of this polynomial, okay? The first thing is first. I want to talk about the degree and end behavior of this graph. Okay, that's the first thing. So what I want to talk about here first is what my degree is. Okay, the degree of this function is 5. Okay, which means that it's going to be odd. All right, and it's an odd function. Okay. So that tells me what my end behavior does. My end behavior means that we're going to go down to the left and up to the right, okay? Because my degree is positive, my degree 5 is odd, okay? And my leading coefficient, that's what we forgot. The leading coefficient is positive, okay? Then I know that my end behavior is going to go down to the left and up to the right, okay? So that's the first thing, to be able to calculate that. The next thing I want to do is factor this out completely and then, go from there and be able to solve that. So I'm going to rewrite my function over here, and it's x to the 5th minus 5x cubed. So I've got f of x is equal to x to the 5th, is it minus 5x cubed plus 4x? So minus 5x cubed plus 4x. And what I want to do is I want to factor out an x, first of all. Okay, so I'm going to factor completely. Okay. And so first thing I'm going to do is I'm going to write this as f of x is equal to, factor out an x, and you're left with x to the 4th minus 5x squared plus 4. Okay? Now, this one's a little bit tricky to factor. You may think that you have to do synthetic division on this, but what I notice is that, when I have x to the 4th minus 5x squared plus 4, I can do this thing called a u substitution. Okay, so I'm going to let u equal x squared, okay? And so then what I'm going to do is I'm going to rewrite this function in terms of u, this part. So I'm going to write it like this. I'm going to write it as u squared minus 5 times u plus 4, okay? And what I notice when I do that, when I let u equal x squared, and this is usually the case when you have x to the 4th minus something x, plus or minus something at the x squared, is it looks like a trinomial that you can factor. And when you do the u substitution, you in fact have that. So the question is, two numbers that multiply to 4 but add to 5, and that is going to be u minus 1 times u minus 4, okay? And then what I'd want to do from here is take my x squared value and plug it back into u, okay? And so then what happens is you get this. You get that f of x is equal to x times x squared minus 1 times x squared minus 4, all right? So now what we have is this. Okay, I have my function f of x is equal to x. Now what I notice here is that this is a difference of squares. X squared minus 1 can be rewritten as x squared minus 1 squared. Okay, and then I have x squared minus 2 squared. So both of these can still continue to factor. Okay, so then I get f of x is equal to x times x plus 1 times x minus 1, and then x plus 2 times x minus 2. Okay? Now, here's the other thing, okay? this is factored completely now. Okay, so this is factored completely. So what I want to do at this point is calculate my zeros. Okay, so I'm going to set each of these factors equal to 0. So I've got x equal to 0, set that equal to 0. Set x plus 1 equal to 0. I'm going to set x minus 1 equal to 0. Set x plus 2 equal to 0. And then I'm going to set x minus 2 equal to 0. Okay, so when I do that, all right, these turn into zeros. Okay, take my factors, turn them into zeros. So this is just going to give me x equals 0. Okay, this one, if I add or subtract 1, this gives me x equals negative 1. Okay, if I add 1 here, I'm going to get x is equal to positive 1. Here, I'm going to get x equals negative 2. And here, I'm going to get x is equal to 2. So these are my zeros, okay? And the interesting thing, these are my zeros, and they all have a multiplicity of 1. Multiplicity of 1, okay? And if we remember what multiplicity is how many times these factors are multiplied. Okay, so what happens is now I'm just going to go ahead and draw these. I've got 0, 1, 0, negative 1, positive 1, negative 2, and positive 2. Okay, and so what I know about this, okay, is that my end behavior goes down to the left and up to the right. And because my multiplicity of 1, that means that at each 0, so the conclusion I make from this is that at each 0, okay, the graph will cross at the graph will cross the x-axis. Okay, so at each 0, the graph will cross the x-axis. All right, that's the idea. So what I want to do then is kind of start off with my end behavior, okay, and draw my function, all right? And so I'm just going to have it look like this, okay? End behavior kind of goes like that. So at each of my last zeros, and then I'm going to go up here, going to goes through, and it going to goes down. So each of these is going to go through the x-axis, and that's the idea. So my function looks like that. Okay, more or less. Okay, these could be a little bit higher, I'm not really sure, but you know, who knows? All right, so what I want to do is I have gone ahead and I have graphed that function. Okay, I had something x to the 5th, meaning I'm going to have 5 x-intercepts. Okay, so let's go ahead and actually graph this on Desmos. I'm going to import it in and see if we actually get the same thing. Okay, and so as you can see, you know, when I plug this into my grapher, we get the same thing. Okay, now these are a little bit more elaborated, but you know, I'm more concerned just about what's happening. Okay, and so we had the same zeros that we had, okay, here, and then we followed the end behavior. That's how I kind of started, and then you just connect the points. But because all of my multiplicity, every one of these had a multiplicity of 1. Okay, meaning the exponent above each of these factors was 1, okay, that means that at each 0, the graph will cross the x-axis, okay? So notice how it crosses the x-axis at each of these, and it goes through, okay? If it had an even multiplicity, then it would have bounced off at one of those, but it just goes through each of those, okay? Okay, we kind of talk about that here, okay? So what I want to talk about here real quick is... you know, here you have a degree 4. Okay, so let's look here real quick. Okay, you have your degree is 4. Okay, so that's even. And your leading coefficient, your number that's way out front, is positive. Okay, leading coefficient is positive. That means that your end behavior, EB, or if you're a Chiefs fan, say Eric Berry, but not many of you are because we're in Colorado. But that means that we're going to go up to the right and down and up to the left. Okay, so you know, up to the left, up to the right, and that's what's happening here. Okay, now what they have is they have x plus 4. Okay, so you have a 0. So your zeros are at x equals negative 4. Okay, that's from that. And then you have x equals -1. Okay, but then you have x equals +3. Okay, now your multiplicity here is 1. Okay, you have an exponent of 1. All right, so you're only multiplying that factor once. Okay, notice how it goes through, okay, at that value. Here, at x equals -1, you have a multiplicity of 2. Okay, now notice here at -2 or -1 how it bounces off. Okay, it doesn't go through that 0. How it touches that x-axis and just bounces right off. Okay, and then here at 3, okay, you had an exponent of 1, so your multiplicity here is 1. So at 3, okay, you go through again. All right, and so that's the idea. That's what happens when you have multiplicity, okay? And if you have odd multiplicity, that means that your graph crosses the x-axis. Even multiplicity means that it touches the x-axis, all right? So kind of a lot going on here, but that's the idea. So I hope you enjoyed this video, and we'll talk to you later. See ya. Bye.